Hi everybody, here's a second video on nomenclature naming associated with alkanes. We're going to take a look at these four examples because each of them is going to bring up a slightly different issue. So let's take a look at this first one on the top left. Again, my first objective is to find the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it looks like my longest chain is going to be 7. So this guy is going to be named a heptane. Now the question then becomes, how do I number it? Do I number it with this being carbon 1 and that being carbon 7? Or is that going to be carbon 1 and then that's carbon 7? Well, it all has to do with where the branches occur. We want to give the branches the lowest number possible, so we're going to number this guy right to left. You don't always number going left to right. Don't be so English speaking about it. Sometimes you'll have to number the molecule right to left. So this is a heptane, and then I have, as you can see, branches on the 3 and the 4. Those branches are 1 carbon long, so those are going to be methyl branches, and there's 2 of them. So the way I'm going to name this guy will be 3, 4 hyphen dimethyl heptane. And that's all one string of characters. At no point did I hit the space bar. I know maybe it looks like I did there, but I didn't mean to. So this is all one string of characters. There is no space bar touched during the course of that naming. Let's take a look at the molecule over here. So this is going to bring up the point that sometimes you have to look up and down to find the longest chain. Where's the longest chain? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ah, but how about this? 1, 2, 3, 4, 5, 6. So if you include what sort of initially looked like a branch in the chain, you can actually make it longer. So the longest chain isn't always going to be laid out nicely on the horizontal. Sometimes you have to go up, down, and every which way to find the longest chain. So here's my longest chain. Now the question becomes, how do I number this? Well, if I start here, I would have my first branch on the 1, 2, 3 carbon. If I go this way, I'd have my first branch on the 2 carbon. So again, this guy's going to get numbered right to left, like so. All right, and again, I have 2 methyl groups, and so my name here is going to be 2, 4 dimethyl, and what do I get? 6 carbons, so that's going to be hexane. 2,4-dimethyl hexane. Okay? All right, let's take a look at the guy here on the bottom left. Now, this structure brings up that some branches get sort of their own name. Let's take a look at this branch here. So the main chain is 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So we're going to number it going this way. That way, that branch will be on the 3 as opposed to the 4 position. So I've got a hexane here. But this branch here, if you look, it has 1, 2, 3, 4 carbons on it, and it's arranged in kind of like a plus sign or a cross. This is a particular kind of branch called a tertiary butyl branch. So we're going to name this guy 3 hyphen tert for tertiary, tert butyl, and then it's a hexane. So tertiary butyl is one of those branches that is kind of special. In the notes you'll see tertiary butyl. You'll also see something called isopropyl in the notes as well. All right, let's get to our last example over here, where we have now a cyclic alkane. We have 4 carbons in a ring. So the question becomes, how do we count carbons? Well, when it comes to cyclic structures, carbons are either in a ring or they're not. You don't get to count carbons both ways. So for example, this carbon right here is a member of this cyclic structure. This carbon right here is a member of the cyclic structure. So carbons that are in the ring really can only be counted as being in the ring. What you can't do is you can't combine this cyclic carbon with these non-cyclic carbons to try to get a longer chain. So you have to count for the longest chain, and your longest chain can either be cyclic or non-cyclic, but you can't combine cyclic carbons with non-cyclic carbons to get a long chain. So what you cannot do is go 1, 2, 3, 4, 5. You can't do that. What you can do is say, okay, I've got a non-cyclic chain of 1, or a non-cyclic chain of 2, or a cyclic chain of 4. And since the cyclic chain is larger than the non-cyclic chains, we're going to name this based on it being a cyclohexane, or excuse me, a cycloalkane. More specifically, this guy is going to be a cyclobutane because it's got 4 carbons in it. Now, in front of that cyclobutane, then, I have a choice. I can either number this carbon 1, then that carbon 2, or that carbon 1, and then that carbon 2. The question is, which way do I go? I'm going to go in the way such that the larger branch gets the lower number. So this guy will then, its name will be finished as 1-ethyl 2-methyl. Sorry, I'm having to squeeze this in. So 1-ethyl 2-methyl cyclobutane. Now, when I name this structure, I don't name the ethyl and the methyl in the order I've shown here because the ethyl is 1 and the methyl is 2. The ethyl comes at the beginning of the name because E is before M in the alphabet. The ethyl got number 1 because it's bigger than the methyl. But when I list the name, I list the branches in alphabetical order. Not numerical order, but alphabetical order. It just so happens that numerical and alphabetical ordering are the same here. Okay, so that's a little bit more about alkanes. Refer back to the handouts, and between these 2 videos and the handouts, you should be pretty good to tackle worksheet 1 and start to name some of your own alkanes here.